Hi and welcome to this episode covering Enterprise Shared File Services with Azure NetApp Files. This is part of the Azure Back to School event run by Dwayne, aka Captain Hyperscaler, and we're going to be running through an action-packed sequence of things. So we've got provisioning storage for Windows servers using SMB, provisioning storage for Unix and Linux servers using NFS, provisioning mixed mode storage, so sometimes if you've got Windows and Linux or Unix servers, how you can do both at the same time off a single volume. We've then got some really in-depth information of performance benchmarks. We can explain how shared storage also accelerates storage speeds higher than what you can even get with local disk than your typical instance size. So I'll be showing how I can give a DS4 tons of performance, for example. I'm going to show backup, restore in just a few seconds, cloning new environments for dev, UAT and pre-prod, showing performance scaling, so storage is a bit boring. Sometimes you need to grow and shrink your storage on the fly. I'll show you how to do that in real time with no downtime whatsoever. I'll then show you how to change full tiers of storage from standard to ultra to premium back to standard again with just one API command. I'm going to explain the pricing of how it all works, and then to really show some of the great features that we've got here, I'm going to show replication between regions that can be set up in just a few seconds that you fully control, can fail over again in just a few seconds. So again, thanks to Dwayne, Captain Hyperscaler, for giving me this slot, and for more information on any of these videos, you can go to the backtoschool.tech website and hashtag Azure Family. So let's get started. There's tons to go through.
Okay, so let's fly through this action-packed agenda. First of all, we're going to provision some storage for Windows. You have a Windows client already running in Azure. On the left, I've got the Azure portal. You're going to click Azure NetApp Files. It's a first-party service directly from Microsoft themselves. You go to EU West, click Capacity Pool, click Add Pool. We'll do Azure Back to School. Pick a service level. So standard, premium, ultra. Ultra offering the most performance, standard being the slowest one out of the lot. Obviously cheapest to standard, ultra is the most expensive. Pick a size, could be 4, could be 500 terabytes. Hit create. We now have lots of storage available, no editing. Let's go and create a volume. Click add volume. Volumes are what store your data. So we want to do Windows shares. So we're going to create one just called Windows. We'll make this 2 terabytes. We go straight into the virtual network itself, so full support for hub or spoke models, no third-party networking required. Pick a private IP address, hit next. We're going to do Windows, so we're picking SMB. There's my DNS controller. Could be an on-premise AD, could be a fully fledged Active Directory, or Azure Active Directory via Azure Active Directory domain services. Hit next. Full support for tagging, and hit create. In that short amount of time, I've just created a Windows file share. No Windows file servers required, nothing for me to maintain, patch, or update. Now let's go and create an NFS share at the same time. So if I've got Linux or Unix hosts in EU West and I want to go and create an NFS volume for them, you can click add volume. This is going to be, let's just call it Unix. This again is going to be 2 terabytes. Put it in the hub, consume a private IP address, this time NFS. I have NFS version 3 and 4.1, depending on your requirements if you need the security or scale out pieces of file locking that NFS 4.1 brings. Support for tagging, and then hit create. And in just a few seconds I've now created a scalable, highly available 4 nines NFS container. So in the last minute we've done SMB and NFS. Next, let's go and create some mixed mode storage. Back into our ANF, back into the EU West, Now the thing is, you'll notice I did a 4 terabyte capacity pool. What happens if I need more storage? Well, that's easy. Resize, no downtime whatsoever. We're going to do 6 terabytes. Hit OK. We now have an additional 2 terabytes of space. Brilliant. Let's go to volumes. Add volume. Now this is going to be our mixed mode one. We'll just call it mixed. This time we're only going to make this one 1 terabyte. So 1 terabyte. Pick my hub, private IP address. There's no public IP addresses on ANF, by the way. It's totally secure, internal only. It'd be like me giving you my 192.168.1.254. You can't get to me. There's no route in between me and you. Again, pick the Active Directory, pick the path, or security style. So if my service is predominantly Windows, I'll use NTFS. If it's predominantly Unix, then I will choose Unix as the security style I want to use. Hit Next, Review and Create, and Create. And that has now provisioned a volume that offers both NFS and SMB simultaneously. So you don't have to worry about moving data between 2 different environments that are Windows and Unix, or having to use the least optimal client. For example, with Windows using NFS client, fully functional, valid solution. However, you're not going to get the full performance as you would with, for example, SMB on a Windows host. So it allows you to choose the preferred protocol for your given environment. Windows can use SMB, your Unix and Linux hosts will prefer NFS. That's all 3 of those done. Okay, so now they're created, let's go and mount the Windows one in Windows. So we click the Windows share that we've just got, and you can click Mount Instructions, which gives you the path. So I'll just copy that to clipboard, head to this host, click Map Network Drive, paste it in here, and hit Finish. And that is enterprise storage at its finest. A few seconds, done. No Windows file servers. Also, just while we're at it, put some files in there. So we've got some large files that we'll just pop on it. And we've got some small files as well. So let's go grab some small ones. We'll put them in there as well. Okay, so they're copying across. Now let's go to the Linux host. So we go back to Unix, which was this one over here. Same again, mount instructions. You can see, make sure you've got NFS installed. We're going to make a quick directory to go and mount this. So just for demonstration purposes, I'll just make one called Unix, and then you run this command. Now bear in mind, obviously this is a generic command. You'll probably have some application specific commands for fine-tuning that you'll use. So for example, one thing on here that's not on here is nconnect, which you can make use of in things like Ubuntu, anything above version 19, which gives you the equivalent of multi-channel, so you get a lot more throughput through it. By default it doesn't show you that, so I can, if I want to, do a sudo unmount, and it was called Unix, or umount I think it was. There you go. And instead of using just this default command, for a little bit of more performance, I can type nconnect equals, for example, try 16. And there we go. And this time now I've got 16 simultaneous connections that will allow me to actually go and get the greatest throughput possible from my provisioned network interfaces, which is great, because it's the same thing that happens with SMB. So now we've mounted that, so we just have to do one final step, which is sudo chmod 777 Unix, and then I can cd into Unix here. Excellent. So that's it. NFS is done, and as we've just seen, Windows is also done. So the next step was backup and restore. Now what you'll notice, we'll use the Windows volume and we'll use our Windows host to demonstrate this, is that you have snapshot technology available. Now don't confuse this with other snapshots, this is very different. Snapshot technology on Azure NetApp Files allows you to take block level instant snapshots, but more importantly, snapshots are the easy bit, is instant restore, and that's massive for any business. So let's take a manual snapshot just to show you how this takes. We've got 2 already existing. We'll do back to school 3. So what we're doing is we're taking a snapshot of that file system at that precise time we create that snapshot, which is great because you can use that with things like application consistency scripts, logic apps, all sorts of things to make sure that the point you take that snapshot is consistent, not just crash consistent, but application consistent as well. Now, let's go back to our file host and let's go and delete some of these files. Let's say small file 1 is the unfortunate candidate that's going to get deleted. Now, I know I said that the snapshots are at volume level, which means I can restore the entire volume. So if I get crypto locked or whatever it may be, I can restore that volume instantly back to its last name state when it was fine. But what about individual files? Well, if you go to View, and if you click Hidden Items, you'll see there's a read-only tilt snapshot directory. And I can see all my snapshots there. Don't worry, no one can change any of the information in here. But let's say I wanted to go and get that file back from before. So there it is, small file 1. All I do is I go to small file 1, go back to the root directory, Control V, and I've just done a self-service restore. Nice and simple. It also integrates with previous versions, so when you right click and see previous versions, you can see all the snapshots in there as well. Nice and simple. Now, snapshots on themselves are not a backup, truly speaking, because if you leave them in a single volume, if you lose that volume, you lose all your backups. However, combine them with powerful cross-region replication technology, and you have all your snapshots available, not just in the primary region, but your secondary region as well. Now, what about if I want to go and clone this environment? Let's say I've got some test or dev that I want to go and do. Well, again, I've got this volume here, Windows. Well, what we'll do is we'll go to a snapshot, and let's say it's this number 3, and we'll hit restore to new volume. Now remember, there's two things you can do. You can restore to a new volume, which is independent. I can go and mount that, we're going to do that right now. Or I can actually restore in place. So again, if you've had a catastrophic error, I can restore the whole volume back to its last known state so business can carry on. So let's restore to a new volume. We're going to call this one Windows Dev. So this could be our development environment. And again, we'll just make this 1024. Next, this is going to be SMB. It's going to be joined to the domain. I can support tagging. I'm going to hit create. This is going to create an entire copy of that without actually taking any impact of waiting for a copy to complete. So it's instantly available to me for my dev and test purposes. So it's now deploying it. And there we go, go to resource. Now remember, let's go and get its mount point, mount instructions. Click copy. Over here. And go back to this PC, computer, map a network drive. Let's map this one as Y. So this is our development environment. There we go. So we've just cloned an entire environment in just a few seconds. And regardless of the size, that could have been 100 terabytes of data. It clones instantly. So that's the cloning. Next, let's show some performance scaling. So what if our volume doesn't have enough performance? And more importantly as well, what about volume tier changes? Right at the start of this, we provision this as a standard tier volume. So we're going to use a great tool called FIO. Now FIO can show you the benchmarking. We'll just hide our dev. You can see Z drive is what we're interested in, so we'll go over to Z. Okay. Now let's run an FIO command. And this is going to show us the performance on that volume. I'll just make it a little bit bigger, if I can. Okay. Now this will take some time because you'll notice I made the volume and it was very, very small. Now in preparation, whilst we're waiting, I talked about moving tiers. And you'll notice on the capacity pool side of things, we've got a 6 terabyte standard tier. Now standard offers 16 megabytes a second per provisioned terabyte. What if we want to go fast, and I mean really fast? Let's go and provision an ultra tier. Now Ultra, by comparison to standard, which was 16 megabytes per second, Ultra is 128 megabytes per second of throughput. So even 4 terabytes here is going to be pretty quick in comparison. So already 4 terabytes of Ultra. I'm going to call this Back to School Ultra. So 4 terabytes of that is now available. Okay, let's see how our file's going on. You can see it's not fast, it's not particularly slow. It's exactly what we provisioned, and we provisioned, going back to it, a 2 terabyte volume of SMB, which was called Windows. Now 2 terabytes of standard is 2 times 16 megabytes a second. That's 32 megabytes a second. But what if we want to go faster? So let's just wait for this until it shows us our I/O. And let's write this down so we can do a comparison. We should see 32 megabytes a second of throughput. We'll also see what that means in terms of I/O as well. So there we go. That's 524 IOPS. Okay. Not bad, not great. Okay. What we're going to do is we're going to change this, but instead of running it for just 60 seconds, let's run it for a little bit longer and just leave it running so we can see what's going on. Okay, so we were at 524 IOPS and 33 megabytes a second, but we need more performance. So with our Windows box, what we can do is the 2 things. Remember, you've got performance per terabytes, of course. I can hit resize and automatically more size equals more performance. That's easy, we've shown that a million times. If you've seen any of my demos before, you'll understand that. However, here's a new thing that a lot of people haven't seen. I can change the entire tier. So I'm going to click Change Pool, and we're going to move it from Standard to Ultra, hit OK. Done. Did you see how fast that was? I might have to replay it. Now let's go. We are now at 263 megabytes per second. Before, we were at 32. Now I haven't edited that. There's no editing at all that's happened there. And we're now at 4197 IOPS. What if we want to go faster? Remember I said you can grow the volumes to grow faster? So now let's go over here. We've got 2 terabytes. Remember when I provisioned this, we had provisioned at 2 terabytes. So let's take it to 4 terabytes. Hit OK. And we should see twice the performance. So before we were at 263 megabytes a second, and now we're at 524. So that was easy. 524 megabytes a second. Or if we're looking at the IOPS, remember we're using a 64K block size here. We're at 84. Let's call it 400. Seems about right. IOPS, not bad. So how does that compare to the actual size of that VM? So this is a DS4v3, and you can see here it says it can do roughly around 64,000 IOPS or 200 maximum burst, 200 megabytes per second. Well, hang on a minute. We're doing 500. We're doing over double what that VM's designed to do. Excellent. So you get to be able to use smaller virtual machines with more I/O. So not only is the performance great, but the pricing model is great as well. So where do you go and work out the pricing? Nice and easy. Go to the normal Azure pricing calculator, click on storage, and Azure NetApp Files is there. Remember what I said right at the start. Azure NetApp Files is from Microsoft. It's their product. So click on ANF, click View, and you can switch these toggles on and off for whatever region you're in. So say I'm in, I don't know, UK South. I want some standard storage. Well, I can have 4 terabytes or 8 terabytes for so many hours. Now remember, you build by the hour, and if I swap from standard to ultra, I can provision those and then deprovision the standard, and vice versa, deprovision ultra, create my standard again. So pricing, very straightforward, no different to pricing any other Azure service. Now finally, what about regional DR? So we had that UNIX volume that we created in EU West, and we're just going to very quickly grab its resource ID to there. And we want to regionally make it available in EU North. So to go and do that, we're going to go and create some space for it. So we'll create a standard pool over here for back to school DR. Now here's a really cool thing with Azure NetApp Files, you don't need to match the same tier as the source environment. This can save you lots of money for DR especially, because you could have an ultra volume in your production environment and you can replicate to a standard volume in DR, safe in the knowledge that if you ever did invoke DR, you can change from standard to ultra in less than a second. So you don't lose any performance and you save on the price, whilst DR is just being DR. So back to school DR, standard 4 terabytes, hit create. We're then going to create what's called a protection volume. So go to volumes, add data replication, give it a name. So we'll call this back to school UNIX DR volume. It's going from this pool, and we'll give it the same size as the source volume. We're going to go in our hub, private IP address, protocols NFS because we're doing the UNIX volume. Next, there's where we paste the source volume ID. Maybe we want to do it every 10 minutes. You can do every hour or daily. This is how often your replication is going to happen. It is asynchronous. Support for normal tagging, and then we hit create. And that is going to create that data protection volume over in EU North. Okay, so our pair has now succeeded. We click go to resource, and here is our DR volume over in ANF EU North. And then to finalize it, what we do is you go get the properties of this destination volume, copy that to your clipboard, go back to the source volume, which was EU West, and go to the volume, which was the source there, which in this case was UNIX. Click replication, authorize, and think of it as a two-way handshake. We tell now the source volume that is a destination volume, and we put in its destination volume ID. It's now authorized, which now means if we go to replication, you can see it's all set up, it's idle, it's going to healthy, everything has been replicated and can be monitored directly in Azure Monitor. So that's absolutely everything, and if I ever need to invoke DR, I can invoke DR in just seconds. You have full control over that process. So thanks for joining me on this session. We've been through an awful lot. Just to recap, we've provisioned storage for Windows servers and clients using SMB. We did it the same for Unix and Linux using NFS. We provisioned a mixed mode storage volume, which was NFS and SMB. We showed you how performance works in Azure NetApp Files. We did backup and restore, including single file restore. We did cloning an environment for dev, UAT and pre-prod purposes, showed how the performance works in terms of growing volumes, shrinking volumes, and also moving tiers. I explained the pricing and where you can go and get the latest up-to-date pricing. And finally, what we've just shown here, which was all of the replication and failover for regional DR. So thanks for joining me. Thanks for joining the backtoschool.tech event. Thanks to Dwayne for pulling this one together. And I hope you really enjoyed it. So thanks very much.